Good morning friends, the last topic of this chapter atoms. Already we discussed about BOHR'S atomic model, right? In Rutherford's atomic model, the Bohr suggested the three hypotheses. And after that, the Rutherford's and Bohr's atomic combined model is applicable for the element. But actually, that is only applicable for the hydrogen atom. That is failed to explain for the complex atom. That means the atom having the more than one electron. At that time, this Bohr's atomic model is not fulfilled the particular things. Here we are going to discuss this. What are the limitations of Bohr's atomic model? One is the Bohr model is applicable to hydrogen atom only. It cannot be extended even to more 2 electrons atom such as the helium. First limitation is that the Bohr's atomic model is only applicable to the hydrogen atom. Now, it cannot be extended even to more 2 electrons atom such as the helium. Right? What are the difficulties arises as we apply the Bohr's atomic model for the helium atom or the atom having the more than one electron? What is that? The analysis of the atoms with more than one electron was not success. Analysis of the atom cannot be success by using the Bohr's atomic model for an atom having the more than one electron. Each electron intact not only with the positive charged nucleus but also with other electrons. While in the hydrogen atom, inside the nucleus the one proton is present and outside the nucleus, that means in circular orbit, only the one electron are present. Therefore, the electric force between the positively charged nucleus and electron take place. That is the electric force, that is the only force of attraction is exerted. While for the complex atom, that means the atom which has the more than one electron, not only the force of attraction between positively charged nucleus and electron take place. Here, the force of repulsion between the electron is also take place. By using the Bohr's model, but the Bohr's model cannot specify this repulsion force between the multi-electrons. The Bohr model involves electrical force between the positively charged nucleus and electron only. It does not include the electrical force between the electrons. That means the Bohr's atomic model cannot include whatever the electrical force between the electron or the repulsion force is not included for the atom having the more than one electrons. So, which is necessary appear in multi-electron atom. If the electron has the more than one electron, at that time the force between the electron is also take place, and also the electrical force between the positively charged nucleus and electron is also take place. But Bohr's atomic model cannot include the electrical force between the electrons, right, which is necessarily for the multi-electrons atom. Again, the first limitation of the Bohr's atomic model, Bohr model is applicable to hydrogen atom only. It cannot be extended even to more 2 electrons atoms such as the helium. The analysis of the atoms with the more than one electron was not success by using the Bohr's model. The analysis of the atoms which have the more than one electron was not success by the Bohr's atomic model. Now, each electron intact not only with the positively charged nucleus and electron, but also with each other. So interaction between the electron is also take place in case of an atom with the more than one electron. Okay. Now, in Bohr model involve only the electrical force between the positively charged nucleus and electron. Right? It does not includes or involves the electrical force between the electron, right, which is necessarily appears in atoms or the multi-electron atom. So in short, Bohr's atomic model only consider the electrical force between the positively charged nucleus and electron, for single electron only. In case of atom which have the more than one electron, at that time the interaction between the electron take place and the electrical force between the electron is also take place. So in Bohr's atomic model for complex atom or the atom having the more than one electron, so this electrical force between the electron is not considered. And that is the necessary for the multi-electron atoms. Okay. And thus the Bohr's atomic model is only applicable to the hydrogen atom, not for the complex atom or the atom having the more than one electron. Second is, while the Bohr's model correctly predicts the frequency of the light emitted by the hydrogenic atom, Bohr's model is successful the predict of the frequency of the light emitted by the hydrogenic atom. The model is unable to explain the relative intensity of the frequency in the spectrum. But the Bohr's atomic model is not explain the relative intensity of frequency in the spectrum. Right? It means in emission spectrum of the hydrogen, the sum of the visible frequencies have the weak intensity other strong. What is the reason? So that cannot be explained by the Bohr's atomic model. Again, in emission spectra of the hydrogen, the sum of the visible frequencies have the weak intensity. Right? And other has the strong intensity. Why? That cannot be explained by the Bohr's atomic model. That thus the Bohr's model is unable to account for the intensity variation. So Bohr's atomic model cannot explain the variation in intensity of the emission spectra. This model cannot be applicable to the complex atom. Again, the second limitation of the Bohr's atomic model is that while the Bohr's model correctly predicts the frequency of the light emitted by the hydrogenic atom, right, the model is unable to explain the relative intensity of the frequency in the spectra. So Bohr's atomic model cannot explain the relative intensity of the frequencies. In emission spectra of the hydrogen, the sum of the visible frequencies have the weak intensity, other has the strong. That cannot be explained by the Bohr's atomic model. Why the intensity of the spectral line are not same, or what is the reason? Some line has the less intensity, some has the strong intensity. Bohr's model is unable to account for the intensity variation. Thus, the variation in intensity of atomic spectra or the emission spectra cannot be explained by the Bohr's model. Thus, this Bohr's model cannot apply to complex atoms. Hence, just we completed the theory of chapter 12. Now, the illustration of this chapter 12 atom. Now listen, before starting the illustration, 12.1 and 12.2, two illustrations are cancelled for board exam. Not cancelled for competitive exam like as the JEE and NEET. Only for Gujarat board exam, these two illustrations are cancelled. Right? But here we consider all illustration and all numerical of exercise. Okay. Now, Illustration first, 12.1. In Rutherford's nuclear model of the atom, the nucleus having the radius is 10⁻⁻15 meter is analogous to the sun, about which is the electron move in orbit radius 10⁻⁻10 meter, like the Earth orbit around the sun. If the dimension of the solar system had the same properties as those of the atom, would the Earth be closer to or further away from the sun? Then actually is it? The radius of the Earth's orbit is 1.5 into 10⁻11 meter. Radius of the sun is given 7 into 10⁸8 meter. Now, first we know what are the letters are given. Radius of electrons orbit that is given that 10⁻10 meter. Actually, there is the radius of the atom. Radius of the nucleus. Radius of the nucleus. Small r, there is a capital R. There is a small r is 10⁻⁻15 meter. After that, the radius of the sun. There is the RS is given as 7 into 10⁸8 meter. And radius of Earth's orbit RE is given as 1.5 into 10⁻11 meter. Here we consider that whatever the electron is rotated around the nucleus is same as the Earth is rotated around the sun. Here we have to compare. If the Earth rotates around the sun is same as the electron rotates around the nucleus in an atom. So, let me consider the ratio of the orbital radius to the radius of the nucleus is same as the ratio of orbital radius of the Earth to the radius of the sun. So in this case, the Earth is how much closer to the sun or far away from the sun? Right? Okay. For that purpose, first we find out the ratio of radius of orbit, radius of electron orbit to the radius of the nucleus is equal to capital R upon small r. Capital R is the radius of Earth's electron's orbit, 10⁻⁻3. Radius of the nucleus 10⁻⁻15 is the 10⁵ times. Thus, the radius of the electron's orbit is 10⁵ times larger than the radius of the nucleus. Thus, radius of electron's orbit is 100 times larger than radius of the nucleus. Right? Now, if this ratio 10:5, if radius of Earth's orbit to the radius of the sun is same as this ratio 10 is to 5. Therefore, I dash is the radius of the Earth's orbit. R as radius of the Sun is 10 is to 5. Therefore, I dash is equal to 10 is to 5 into RS. Therefore, I dash is equal to 10 is to 5 into radius of the Sun, 7 into 10 is to 8 meter. That means the 7 into 10 is to 13 meter. There is the orbital radius of the Earth around the Sun. But orbital radius of the Earth is given 1.5 10 is to 11 meter. But orbital radius of the Earth is 1.5 into 10 is to 11 meter. Thus, new orbital radius is 100 times more than actual orbital radius. Because from the calculation we obtained the orbital radius of the Earth is 7 into 10 is to 3 meter. But orbital radius of the Earth around the Sun is 1.5 into 10 is to 11 meter. So, obtained orbital radius is approximately 100 times larger than the actual radius of the Earth around the Sun. Right? And therefore, the Earth is 100 times far away from the Sun. So that Earth is 100 times far away from the Sun. Right? Okay, this numerical first. Here we consider the electron is revolved around the nucleus same as the Earth is revolved around the Sun. The property of the both cases are same. That means the ratio of orbital radius of the electron to the radius of the nucleus is same as the radius of orbit of Earth around the Sun to the radius of the Sun becomes the same. So what is the distance of the Earth from the Sun? For that purpose, using the data, first we find out the ratio of radius of electron's orbit to the radius of nucleus. We obtain that is the 10 is to 5. This ratio is same as the radius of the Earth's orbit to the radius of the Sun. So we can find out by using this concept what is the orbital radius of the Earth around the Sun. Here we consider the both ratio are equal. So in this case we obtain the orbital radius of the Earth around the Sun is 7 into 10 is to 13 meter. But actual orbital radius of the Earth is 1.5 into 10 is to 11 meter. So new orbital radius of the Earth is 100 times more than the actual orbital radius. So that we can say that as we consider the both are same for the properties of the atom and Earth for the planetary system. At that time the Earth is 100 times far away from the Sun compared to the actual distance. Right? Now the second illustration is that in a Geiger-Marsden's experiment, what is the distance of the closest approaches to the nucleus of 7.7 MeV energy of alpha particle before it comes momentarily to rest and reverses its direction. Already we discussed in Geiger-Marsden's experiment. So the alpha particle is bombarded on the atom, that is the nucleus. Nucleus is positive charge. Alpha particle is also positive charge because these are the helium nucleus to Ac4. This alpha particle with the energy 7.7 MeV electron volt are moving towards the atom, that is the gold coin, having the atomic number is 79. Therefore, the charge of the nucleus is Zd. There is also positive charge. Alpha particle is also positive charge. Due to the initial kinetic energy of the alpha particle is 7.7 MeV, the alpha particle is moving towards the nucleus of the gold, and also outer orbit of the nucleus of gold, electron are involved. So first the force of attraction is exerted on alpha particle by the electron. When this alpha particle enter inside the atom and approaches to the nucleus, now the repulsion force is exerted on this alpha particle due to the positive charge of the nucleus. Right? When the repulsion force by the nucleus and kinetic energy becomes equal, at that time for one moment the alpha particle remains stationary, and after that they start or its reaction of motion is get reversed. Suppose this closest distance between the nucleus and alpha particle is this d distance. Is the d distance. Right? So initially all the energy of the alpha particle is in form of kinetic energy. When the alpha particle is momentarily becomes the stationary or at rest, at the time all the energy is in form of potential energy. Here we are using the concept of law of conservation of energy, initial energy to the final energy. Initial energy is kinetic energy and final energy is in terms of the potential energy. Therefore, kinetic energy is equal to potential energy, and we can find out the closest approach distance. Clear this thing? Again, the alpha particle is moving with 7.7 MeV energy towards the nucleus of the gold coin. Gold has the atomic number 79. Therefore, the nucleus of the gold has the charge is Zd, and this charge is positive. Alpha particle is the helium nucleus, so its charge is 2 electron, 2e. Initially, with kinetic energy, alpha particle is incident on the nucleus of the gold or the atom of the gold. Initially, the force of attraction exerted on alpha particle by the electron revolves around the nucleus of the gold. When the alpha particle reaches very close to the nucleus, so nucleus applies the force of repulsion on alpha particle. Therefore, the kinetic energy of the alpha particle is going to decrease. When the kinetic energy becomes the approximate zero, for this moment the alpha particle remains stationary or comes to the rest. So in this situation, suppose the distance between the nucleus and alpha particle is d, that is known as the closest approach distance. Our aim is to find out this distance. For that purpose, we are using the law of conservation of energy. Initial energy is in form of kinetic energy, and final energy is in form of potential energy. Clear? Okay. Now, for that purpose, we assume that suppose a distance d, suppose alpha particle at distance d from the nucleus of the gold comes to rest. Comes to rest. Potential energy of the system at distance d is u is equal k q1 q2 upon r is equal to k charge of the alpha particle 2e charge of the nucleus of the gold Ze upon r. Therefore k into 2k Z square upon r. That is the equation 1. Now, from law of conservation of energy, initial energy, total energy of the alpha particle is equal to final energy here. Therefore, kinetic energy is equal to potential energy. Kinetic energy already given, and potential energy is 2k Z square upon r. K is the Coulomb's constant 9 into 10 is to 9. This K is kinetic energy. And here distance is d. Here the distance is d. Because here we assume that at d distance the alpha particle comes to the rest. Therefore d is equal to 2k Z square upon. Here this K is the kinetic energy. Now substitute the value. Therefore d2 Boltzmann constant 9 into Coulomb's constant 9 into 10 is to 9. Z 79 E 1.6 into 10 is to minus 19 joule upon kinetic energy 7.7 MeV. MeV that means the 10 is to 6. Therefore 7.7 into 10 is to 6 electron volt. Now convert to the joule. We have to multiply by 1.6 into 10 is to minus 9. Thus we obtain 295.4 into 10 is to minus 16 meter. That is approximate 30 into 10 is to minus 5 meter. That is the closest approach distance of the alpha particle from the nucleus. At this distance, the alpha particle comes at the rest. Clearly, only we have to apply the equation of the potential energy is equal to the initial kinetic energy.